me, because a lot of people, they just care about whether you can really do it, not necessarily whether you can talk about it.
I want to get hands-on,
Yeah, that's where most people are. Anyway, so, yeah. All right, folks, let me interrupt you there. You're going to go, yeah, what's your question?
Would you touch on those main routers that allow the traffic on the internet? They used to be in the US. Are they still in the US or no?
Would you what?
Yeah, there was, I think, 12 main routers that they...
You guys are going to have to stop talking. You can go out if you want to talk, but I can't hear if you guys are talking. Go ahead.
Those main routers in the internet that used to be in the US that allow the whole internet traffic.
Well, of course,
Can you mention those too?
do they?
Well, are they still in the US or?
Well, this is actually a touchy point. For example, if you're in France and you go to a company in France, your traffic does not go through America, but your DNS resolution for the entire .com domain does go through America. So technically, some of the travel packets do pass through America, and about 3 years ago, the US government announced that they wanted to prosecute people in France for downloading stuff from French servers, claiming it was violating US law and under our control for this reason, that the DNS resolution actually passes through an American company. And they also tried to seize an Irish court, or I think they wanted data that Microsoft had on Irish people in Ireland. And they declared that they had to bring it back into the country to give them data. Microsoft tried to say it was never in the US, it's not your property anyway. There are arguments about this on both sides and lawsuits and everything. It is in fact pretty tricky. And there has been a movement by European groups to try to remove the United States from controlling DNS the way we do. We are the people running the DNS backbone. And now there are pretty strong arguments that we are corrupting our administration of the internet with political agendas that are controversial. So there have been people talking about replacing DNS with a new system that's distributed and international and based on something like blockchains, but none of that has happened yet. There's a small group of activists trying to come up with an alternative to DNS and stop using the .coms and everything because it's all controlled by the US government. And there's just not enough trouble yet that enough people are motivated to do that. But certainly it does mean the United States has a unique place on the internet. We run so much of it that we control a lot of the internet. And lots of other nations are not really happy with that. Like Iran declared, they're so fed up with us that they want to make their own separate internet, which will be halal, and they'll have their own servers and their own content and their own operating system, so they're not playing our game anymore. I don't think they've done it yet, but they said they were going to do it. And North Korea, like I say, is doing something similar, making their own OS, so the government can monitor and control everything you do. But so far, almost nobody has found any problem large enough to motivate them to spend the money it would cost to reproduce all the stuff you can get for free or cheap with American services. Yeah?
Even if you made their own internet and whatnot, they still have to do the transfer of the zones, or how's it going to get the rest of the community in the world?
Well, Iran said they were just going to disconnect from the rest of the internet and you guys can just go away. They don't care. They said we'll just have an internal network in the country that only has stuff we approve of, and will be air-gapped from the rest of the world, which I assume is probably a response to us hacking their nuclear isotope separators. I mean, we really hacked them over and over and over until they're pretty irritated with us. And that would be one way, air-gap the whole country. As long as your citizens don't feel as long as you can compel your citizens to go along with no more internet, which is what they do in North Korea. Most everybody has no internet. I mean, maybe your citizens will put up with that. Yeah.
Speaking of North Korea, they keep launching those missiles. Yeah, they do. Everybody think, some people, I've heard that used a couple of times, and I think so too. Yeah, I think they're hacking those missiles. That's why
Well, that's another problem. Since they don't hardly use computers or the internet, we can't hack them. That's why we were able to hack Iran, because they were using German they were using German PLCs, which we could easily get cooperation from. They were using our equipment, so we could sabotage that equipment. But I don't think we can do much in North Korea because they're not on the internet, they're not using our equipment, and we can't smuggle spies in because they stand out, so it's a problem.
But as you said, it's not possible to hack a missile when it takes off.
Well, you certainly can hack a missile, but if it's not connected, if none of the systems controlling it are connected to the internet, the only way to hack it is to somehow get in physical contact with it. And so you need
a radio signal to it or something?
Well, I'm sure they're trying. And maybe that's why it's crashing. It'd be nice to think so. You're absolutely right. I mean, it'd be nice if we could somehow sabotage the missiles, but that was the whole Reagan. Reagan wanted to build lasers that would zap them on the way across, and everyone said it was impossible, and he did it anyway, just sort of as a theatrical stunt to scare people. But we're putting, in South Korea, I think we did put in a missile shield to try to shoot them down on the way out, which is making China very nervous. It's sort of like a Bay of Pigs was here. It's a big issue. Anyway, so firewalls are the next thing beyond routers. Routers are really just there to move the traffic, and they can have some security contribution in that they limit where the traffic will go. But a firewall is the first thing that actually deliberately throws away traffic because it detects that it's bad. So you can filter traffic on the way in or on the way out. Unfortunately, almost everyone filters only incoming traffic. This is one of the philosophical issue here is called the tragedy of the commons. There are many situations where individuals can benefit by doing something that hurts society at large. So a company, you protect your company by filtering incoming traffic so that bad things don't come into your network. But if you filter outgoing traffic, you're protecting other people from your infected machines attacking them, and that would benefit other people and not you. So some people, egress filtering is so important, it's part of BCP 23. There are best current practices on the internet specified by the committees, the IEEE that made it, and that was number 23, was you should filter the outgoing traffic to stop obvious attack traffic, but most people don't do it because it expends their money and helps their competition. Anyway, so hardware firewalls sit on the edge of your network like a router, look like this, they'll be in a rack. These things can handle lots of traffic, so they'll have all the traffic for your whole company passing through it, and therefore they usually subject it to a very cursory examination because they have to keep it flowing. So they block things on simple filtering rules, and you can't put too many complicated filtering rules in them, or they can't handle traffic at line speed anymore because they have to spend too much CPU time processing each packet. Software firewalls run on the machine you're protecting, like the kind you get built into Windows. You can download other ones. And now this has much more information. It now knows which application on the machine is listening. It can look at system log files. It can do much more to filter packets and decide if they're good or bad. But it's dependent on the operating system of the one machine it's protecting, and it's only protecting that one machine. People typically have both of them, and that's something you'll have over and over again is defense in depth. You have a security measure, and in case that fails, you have another security measure behind it to give you another chance to stop the attack. So that's the point. Software firewalls. One very strange thing about consumer software firewalls is they will pop up boxes like this. I don't understand why anybody thinks it's a good idea to ask the end user a question like this. Firefox is trying to act as a server. How many people have any idea what that means? What happens is these boxes pop up and often have things like port numbers in them. People just randomly click yes or no, and then they call the help desk. And they say, my computer's not working. And they say, what did you do? And they say, I didn't do anything. A bunch of weird boxes popped up, and I got rid of them, and now I can't read my email. I don't understand why anybody thinks asking the end user is the right way to solve this problem, but a lot of these products do. Anyway, so other things firewalls do is translate addresses to conceal your local network. A lot of people regard this as a really important security measure, and it was in fact required by PCI compliance version 2, and it was required by the US government requirements, the one that they all have to fit, not just the military. I forget the name right now, but there's an acronym for the US government requirements for all government computers, and this was pretty interesting. I know a guy named Joe Klein, and he's an IPv6 expert, and he's always given talks about IPv6, and he went to an IPv6 implementers conference at Google with me, and there were people up there talking about how they'd converted their network to IPv6, and he said, how did you manage to get compliance with the government regulations? And they just said, shut up, shut up, shut up, because they're all breaking the rules, because they built network address translation into the rules, and you can't do it in IP version 6. You're not supposed to. It's designed to avoid it. So technically, you're no longer in compliance with the out-of-dated rules when you go to IP version 6. Anyway, so we'll talk about these technologies. Network address translation assigns local IP addresses to the machines that are used only locally, and then they translate the address and the port on the way out in the most common arrangement. So if you have a router here going to the internet, you have a public address like 147.144.21, your internal machines get local addresses like 192.168.1.101, and you can have as many as you want. And if this machine has one browser window open and this machine has two browser windows open, you have three network sockets connected, and this router has a table that translates them all into sockets like this. or they all have the public address and a different port number, so it changes the address and the port number, and this way, from the outside, you appear to have only one computer with 3 windows open instead of 2 computers with 1 and 2 windows open. And that's fine. It means that nobody can run a server down here. That is the only security advantage of this. There's 2. In the first place, you don't even know how many machines people have from the outside. In the second place, you can't run a server. If I open port 80 and start listening for web traffic here and try to serve up a web page, this machine can see it, but nobody else can, because I'm listening on 192.168.1.102 port 80. That address cannot go to the internet. It's private reserved range. So the only public address is here. And so the only way anybody can see that server is if I configure this to do port forwarding, where it will tell it when you get a request for this address on port 80 from the outside, forward it to this machine. And that's what most people want. This way you can have a company and a student lab like this where the students are doing who knows what, but unless they have the password to mess with the CCSF main router or firewall, they can't really serve up a page to anything off campus. You can only the official page that's approved up by the firewall can be visible from the outside, and that's the idea. Yeah.
You know, I see one case that within the internal model, all devices are NAT. Every server.
Yeah.
Another overkill.
It is, and this is part of the problem with IPv4 exhaustion. There are companies, I think Sprint phones, for example, are behind 2 layers of NAT for IP version 4. And they were talking about this. If people refuse to upgrade to IP version 6, there will come a time when you pay your internet service provider and you get a private address like this. You're not even publicly on the internet. All traffic has to be forwarded from your ISP. And so then you're going through more layers of hopping and translation. And the problem is those processes are not perfect. They slow down things and make you lose games, and they also break connection protocols. Network address translation is greatly condemned by the IEEE. It messes up many network protocols. There's a whole lot of things you cannot do on this kind of device. The only thing you can really do is be a client. If you want to run servers here, you can't get GRE in, you can't get IPv6 tunnels. A whole bunch of protocols cannot move in these private networks because they don't make it through the translation process. And so that's why in IP version 6, they're strongly trying to get rid of this. It is possible to use network address translation in IP version 6, but it is strongly recommended not to. You should have, because you have plenty of addresses, you'll never run out. Everyone should just have a straight up public address. Then you can filter traffic here so unexpected incoming SINs are rejected, which prevents people from running unauthorized servers, but you don't have to break the one-to-one connection path because a great number of internet protocols would like to have the IP address of the endpoint and the IP address of the server so they can talk to each other, not some intermediate device pretending to be it. Anyway, that's why it's kind of funny. A lot of people do, in fact, use IP version 6 NAT, and the IEEE guys will punch you in the face if they catch you doing it. Anyway, so you can have access lists on your firewall. This, like I say, your firewall can do simple filtering just based on IP addresses and port numbers and protocols, like a layer 1 firewall. That's the same thing a router can do, but that's one option. But most firewalls can do more. This is called simple packet filtering, where you just have certain packets and protocols allowed in, and if it's a host-based firewall, you can even specify which program is allowed to use the internet. Stateful packet inspection is the next step up. This, I think, was the Generation 2 firewalls. This remembers the history. So if you look at your computer, there are 2 kinds of information you can use to route packets. If I do ifconfig en0, I have an IP address on my Ethernet interface, and you can see it here and so on. So if I do netstat -an pipe more, I have the network connection status. So I have this address on that port number locally. It's connected to this foreign address on 443, so that's an HTTPS connection in my browser, and that's established, which means, as you did in the projects, there has been a handshake. SYN, SYNAC, ACK. That establishes the connection, and it remains as long as you use it, unless it's torn down with a reset, which hangs up on it, or a fin, which terminates it normally because you're done, or it times out just from inactivity. So my browser has been just sitting there neglected for a while, and you see this connection is in the close wait state. It's timing out, and eventually it will be gone. So if I get an unexpected incoming packet, and it's part of an established connection, a stateful firewall will let it through, because it has access to this table. This is what the Windows firewall does by default on a public network in Windows 7 and later versions. If you go into a coffee house and connect, Your machine is a client but not a server. So if someone tries to access your shared files by sending a packet to port 135 to get to Microsoft file sharing, your firewall rejects it because it's an unexpected incoming traffic. But if I connect to something else like a website from the inside and make an established connection, once I make that connection, anything that server sends to me, I accept because I asked for it. So you can get anything you want by asking for it, but you do not offer any service to anybody else if they ask you for it. That makes you a client but not a server, and that is a very safe way to be. When they added this feature to Windows XP in Service Pack 2, they tested it, and a Windows XP before Service Pack 2 machine, if you connect it to the internet and do absolutely nothing, it will get infected within 1 day. But if you turn on this firewall, it will take a year before it gets infected, because it's quite an effective measure, and that's stateful packet inspection. So you look at not only the packet that's trying to get in, but you look at that state table to see if it's part of an established connection, and you use that information to decide whether to let it in or not. And that's the state table there, another picture of the same thing. This is why ACK scans can be slightly useful. If you send ACK packets to somebody, you typically get nothing back, although under certain conditions you might get a reset or an ICMP packet back if you arrange the TTL to run out. And if you have firewalls that are not stateful, they have to let ACK packets through, because for all they know, those ACK packets are part of a TCP session in progress. And since they are not stateful, they can't check to see if it's part of a session in progress, so all TCP connections won't work unless they let ACK packets through. So you can actually probe 1 or 2 steps past some firewalls with ACK packets when no other packets can get through. Anyway, that's stateful packet inspection. This is, all right, so stateless packet filters are less effective against some kind of attacks because they don't have access to that state table and they treat all traffic the same. But what most people want now is application layer inspection. It's not enough to just filter on port number and such, because you have things like BitTorrent. BitTorrent clients will scan the network and hunt for a port to use. Skype will scan the network and hunt for a port to use. So it'll use a different port all the time. If you're blocking by port number, you won't be able to stop it. If you want to control that stuff, you need an application layer firewall, which was very controversial when it first came out like 7 years ago, called deep packet inspection, where you look at the whole content of every packet, deciding whether to forward it. And now you can look at the URL and decide it has Facebook in it. I hate Facebook, I'm going to block it, even if it's going through an unexpected port or to an unexpected IP address. You can protect your company with just one firewall. This was Microsoft's official recommendation until about 2002. They thought one firewall to protect your network is then all the machines inside your network are trusted, and that'll work, but it's no longer true at all because people are bringing in laptops and iPhones and iPads and all sorts of USB sticks. There's no way in which the machines inside your network are trustworthy. They're mixed, full of dangerous things, just like the machines on the internet. So now you need defense in depth. You need a firewall protecting the network, and you need another software firewall on every machine, and you really need to segment your network into zones of trust, so that there are several barriers limiting where you can go inside there. If you don't, you'll be greatly humiliated when you get hacked and the world finds out. Just running a flat network is considered a laughable security blunder these days. Anybody that doesn't have layers of security inside their network is like 10 years out of date and just asking for it. So you should have a DMZ, at least. This is the simplest, this is the first step of network segmentation. You have some part of the network where you let public servers sit, like your email server and your web server, that are going to be exposed to the whole internet, and they have some firewall blocking traffic to that. So the internet is out here. You have this, you might not have to connect directly. Usually you put some kind of firewall here to stop obvious attacks, but these things are high-risk machines. They shouldn't have any secret data on them. They're things that everybody gets to all the time, and when you get hacked, you probably get these things hacked. And so then you have another more strict requirement before they get to your internal network, where you have your proprietary secrets, your credit card numbers, whatever it is you value is here. And this is the beginning of the process of network segmentation, which goes much further. The college has over 100 VLANs. We have 100 different networks, which is a very good idea. The student labs should be separated from like the machines in the registration office and the finance office and wherever they handle the grades and all these. There's all the administrators writing grants. There's all these different levels, and they're separated. So if somebody compromises something in a student lab, they have other barriers before they start getting into everything else. That's the way every network should be. So here's the more common way you do it. You have one firewall even protecting your public stuff so that stuff that is just obviously malicious doesn't get in. And then you have a more strict rule here, like perhaps even a VPN, where somebody has to actually have a password and prove that they are a company employee to get in here. It's not enough to just be a random person on the internet. All right, and so there's a lot of firewalls out there. Cisco is big in this market too. Their ASA is one of the ones that replace the PICs, and these things are used by a lot of companies. One of the most popular firewalls. It has its own configuration language, like their routers. By the way, whenever you log into a modern website, it tells you to go away and get lost. This is because there really was a lawsuit like 20 years ago, back in the early days of phone phreaking. There was a guy that dialed all the phone numbers until he found like the main router going into the telephone system, and it said, "Hello, welcome to AT&T, please log in." So he tried like 1,000 passwords till he got in. And when they went to court, he said, "It said, please log in." That's what it said. And he got off. They said, "You know, you didn't tell him, no trespassing, you didn't tell him to get lost. He logged in. He's right, you invited him in, so now everything you connect to tells you, get lost." Anyway, this is like Kevin Mitnick. When they caught Kevin Mitnick, he led the FBI on a run. He was the #1 most wanted guy for a year and a half in the 90s. They finally caught him, and they couldn't convict him of anything. Nothing he did was actually illegal. He finally spent 9 months in solitary confinement for the theft of a $10 phone manual, because that was the only thing they could find in what he'd done that was actually covered by any laws at that time. And he hacked the phone network like crazy. He made the FBI phone, he intercepted their calls, he rerouted everything, but there were no laws covering any of that. Anyway, so you have an access list in there, which will just have these rules. Access list permitted from this IP range to that IP range, but deny anything else, this sort of thing. You have these rules you have to type in this language to program your firewall. And you can totally learn that stuff here, at least the router side of it we cover here. I think we have, I'm not sure we have specific classes in the firewalls, but it's very much like the routers. Anyway, so the ASA, you can set up groups of objects and filter traffic from one group to the other group and all that. And it runs very fast, of course. You can protect a whole enterprise. All the traffic goes through it. And there are a bunch of online resources where you can get recommended configurations for these devices and recommended ways to set up your different kinds of networks. Just like Microsoft has these, they have recommended security settings for a domain controller or a web server or a database server and so on. Red Seal is a commercial tool. This is compliance. And I just found out, which annoyed me, that's not going to happen next semester, but hopefully the semester after, we will have our CISA course here. And if you would like to get a job, and you would like to actually go home at 5 and see your kids, an area to go into is compliance. See, the pen testing is like being a gunslinger. It's madness, and defending networks tends to be madness too, because stuff happens, like a server goes down, or something under attack, and you have to stay there late at night. So those are for like the cowboys. But people who would like work-life balance need to move away from the emergency services part of it over to the steady employment part, and that's what auditors do. Auditors are like financial auditors. They aren't fighting bad guys. They are making sure you are in compliance. There are a bunch of rules. Like if you take payment cards, there's all these things you have to do. Stuff has to be encrypted. The passwords have to be changed. People can't be adding unauthorized devices to the network. There's a whole bunch of things, and you have to have inspections and devices monitoring the traffic to make sure that all that is happening, and you have to prepare reports and submit reports proving that we are in compliance. And those are compliance officers, and you get tools like this, Red Seal and other tools. It's comparatively boring, but you get to go home at 5 because you're not the person handling the emergencies. If we got hacked, you're the people like doing the taxes. You have to fulfill these reports proving that we have obeyed the regulations. And as the internet matures and the government regulations mature, there are more and more regulated companies that have to prove that they have done this and that. Security people like to complain that compliance is not security. It is the minimum security. If you really want to protect your customers, you should probably do more than this, but at least you have to do these 10 official things. Anyway, so I got a few eye-clickers about that stuff. I think there's a section after this. Yeah, all right. So, all right, what's your first line of defense that removes stuff that is obviously malicious? Well, all right, I'll quit at 25. Looks like the answers are in. All right, you typically have a hardware firewall that can handle all the traffic for your whole network and give it a fast cursory inspection to get rid of the obvious junk, and then let the more sophisticated devices later chew on what gets through. So what device pops up users messages like that? I'll quit at 25. All right, and that's a software firewall. And you'll notice they tried to make it a little more user-friendly here. This program is clean. We recommend to allow it to connect. And like I say, at the college, it's apparent to me that they just subscribe to some service that makes this decision for us. And that's why a bunch of stuff is blocked that seems kind of senseless. That's what I imagine. And that's certainly what end users should get, is just the typical home package or something, instead of asking them questions like this. All right, which technique is vulnerable to an ACK scan? All right, I'll quit at 30. All right, and those are the Generation 1 firewalls, the stateless packet filtering. If they just look at packets one by one, then they really can't decide what to do with an ACK packet, and they have to let it through. Because for all they know, that ACK packet is responding to a request like a SYN that came from inside. And they have no way to know that's not true. All right, so the more sophisticated devices are IDS and IPS devices. An IDS is like antivirus for your network. It monitors the traffic and looks to see if the traffic matches a pattern of known attacks, and if it does something about it. Now, strictly an IDS is a passive device that never blocks anything. It just puts a log entry somewhere or alerts the administrator somehow that something bad is happening and lets the administrator decide whether to block it. So you can have network and host-based IDSs. A network-based IDS is typically monitoring the traffic, and what's good is to get a layer 1 or layer 2 device, like a switch with a span port, that sends an extra copy of every packet up to the IDS, which will go over here. The IDS is this machine over here, so that you can't even detect it on the network. The IDS does not have any IP address. It is not the target of anything, and if somehow someone was able to compromise it, it can't be remote controlled because you can't send commands to it because it doesn't have any IP address. It only has a MAC address at layer 2, and it gets a copy of every packet, which it analyzes. So this is great because then if you do get hacked, you can look at that log of packets and figure out what happened. So recording all the packets and just saving them for a while is a good monitoring security measure. Then if anything bad happens, you have a really good way to find out what happened. And there's no way, just out here, any hacker taking over all this stuff can even detect that this is happening. An extra copy of the packets goes somewhere. So that's a cute way to do it. A host-based IDS is like antivirus. You put it on a machine, it now has access to the logs of that machine and everything else like Snort. And active IDSs not only detect attacks, but they block them automatically by doing something like changing firewall rules. And those sound pretty good, but the problem is you can trick them. And there's a product called Mucus, which is a hacking tool, to attack Snort. And what it does is it sends a bunch of attack traffic so that Snort will freak out and block the rule. So you can cause a denial of service with a fake attack if you have an IPS. So that's the problem. That's why a lot of people do not let the IDS automatically block stuff. It all just goes to a human that has to make an informed judgment about whether we really want to block this stuff or not. Yeah?
So IDS also act like a honeypot?
No, because a honeypot actually tries to attract attackers by appearing to be important, like it looks like a domain controller, it looks like a database server full of credit card numbers or something. The IDS detects attacks, but it doesn't try to attract them. So you can buy IDSs. There's free and pay ones you can get. Snort is the most common open source one, and there's a lot of others out there, and it is a big job. The firewall administrator is an important job at all networks. There's always steady employment in that. Firewalls are very complicated, hard to set up. Our CCDC team had great suffering over the firewall. That's one of the things. If you take 140 and you want to compete in the CCDC, you have a company network you have to protect, and it has an enterprise class firewall, and you have to get all these settings right so it lets the good stuff through and blocks the bad stuff, and it's not simple. So web filtering is where you want to, the most common thing you do is you trick somebody into downloading something. You put up a link or you send an email attachment and they run it. So firewalls won't block this because it's too subtle for them. They allow you to download something, it comes, they don't usually inspect all the contents at that kind of depth. They can't detect like there's a virus in that file you're downloading. They only detect network attacks. So if you want to have web filtering, then you're blocking what websites you go to, and that's called, that's another kind of firewall. You can get a web application firewall to do that, and a proxy server, and you can also use things like OpenDNS that will change the DNS resolution so that if you try to go to a no malicious site, it won't go there. Anyway, then there's drive-by downloads where you just view a website and down come things. So anyway, most companies now have a security operations center, at least the bigger ones. The college doesn't, but the bigger ones do. You have a network operations center where people just try to make sure that traffic is still flowing, and you have a security operations center where you're monitoring it, and there will be a class next semester, CNIT 50, Network Security Monitoring, where we'll learn how to set this stuff up with Security Onion. We will be setting up a network security monitoring software, and you'll see how it works. That is the modern way to do it. This is what they call SIEM systems, SIEM, Security Information and Event Manager. It's a server that gets logs and alerts from all the devices, from the routers, the IDS, the firewall, the antivirus, the switches. Everything is sending, all the servers. You collect all the data you can, and in this one central place you have a tool to detect attacks and search through it. Snort, for example, or not Snort, but Alien Vault, another product of Splunk. Splunk is what they call Google for network traffic. You have all this data and you have a search engine and you can type in queries and detect SQL injection attacks in progress and so on. That's the game here. So this all came about because of the Aurora attack, really. This was in December of 2009. This is what caused everybody to switch to a much more sophisticated way of defending their network, because this is what blew open the internal open secret that we were all getting hacked by China. The Aurora attack was Google in December. Google had opened a branch in China, and the Chinese government had infiltrated them and stolen their stuff and then betrayed them by hacking into Google's main servers in Mountain View, which they saw as an insult. It was like Christmas Day. The founders of Google got a call saying China is hacking us, and they're like, those rotten bums. I mean, here we are, trying to expand our business with them, trying to partner with them, and then they hack us. So they went public and told the whole world about it. Nobody else had been angry enough to do that. So Google hacked in and stole their data, and Google, in response, hacked the Chinese server and stole it back, which was equally illegal. Now, there are no laws at this level. There's no court above the U.S. and China. There's no judge. There's no agreement. So the only thing you can do is start a war. So you can't exactly say China broke. Anyway, so Google did it to China, China did it to Google, and Google just did it right back. And when they did, they found everybody else's data on that server, Microsoft, Adobe, and everybody else, 30 other companies, and they told the other companies, you've all been hacked too, and you didn't even notice. The reason Google noticed is because they had data loss prevention. They were monitoring the outgoing traffic to see if secrets were leaving, and they were. There were our PDF files, our intellectual property is going to China. Why is our stuff going to China? That was the clue that led them to discover this. Most people don't monitor their outgoing traffic for that sort of thing, and they don't catch on. And most companies only find out they've been hacked 18 months later when the FBI comes to them and says, we found your stolen data somewhere on some criminal server. Yeah?
Why didn't the Chinese restore the information to a system that's has an air gap in it so they can't come back?
Well, you know, they're incredibly brazen, the Chinese are. I don't understand Chinese culture, but they just don't hide their attacks at all. We're analyzing like crazy. They hack you directly from major Chinese military and educational IP addresses right next to the military. And we have videos of the teachers in class having the students guiding them hacking American companies. And then when you say you did it, they say, no, we didn't do it. You're just lying. We never hack anybody. You're just defaming us. I don't understand this, but that's what they do. They don't bounce off proxies. They don't hide it at all. They're blatant as hell, and then they just lie right to your face. That's how they cope. And in America, you would like hide and then lie, but I don't know. Anyway, so here's the game. You trick a user to visit a website, then the browser puts a malware on that machine. You click on a link or something. Now that one machine is owned. Now it calls home to a command and control center saying, I now have owned this machine. What should I do? Then you try to escalate to administrator on that machine. Then you look for hashed passwords and use a pass-to-hash attack to wander around the Windows network until you find a high privilege machine or machine that administrators logged in and find a high privilege hash, and then you get on the domain controller and become domain administrator. And then you can now get to the VPN server and steal VPN credentials and get a VPN just like a real Google employee, and now you're in. And they were really serious. This is the advanced persistent threat. This is not smash and grab. Typical like political stunt hackers will steal a bunch of credit card numbers, dump them on the internet, and the game is over. These guys want to perform espionage forever, so they plant malware on your machines that will secretly steal stuff and send it back in small packets late at night so you won't see it. And they have hidden malware that will wait and wake up later. And they had malware that would sleep for up to 3 years and then wake. And so when you think you cleaned it and everything's fine, 3 years later, boom, you're owned again. Because they're not messing around. This is the military espionage. These are the smartest people in the world with all the resources in the world, and they want to own your network, and you're toast. No firewall, no IDS, no antivirus, nothing you can buy is going to save you, just like nothing would save you if the NSA's after you. Good luck. I mean, so this was the recommendation. I remember I used to laugh at how this is impossible, but this is what people are really doing now. After you inspect your DNS traffic to see what's happening, monitor the network for security. And this, by the way, is even more. The privacy advocates will go nuts, but of course, at a company property, on a company network, you have no privacy. The company has the right to inspect everything that's going on the company property, and indeed, they have to. There have been lawsuits where people went to work and then they sent out like bigoted hate speech on the company email server, and the company was held liable for that, saying you should have been monitoring what people are doing on your email network. So you have to read the emails. That's one of the grunt jobs in security, is reading all the emails. But anyway, you control inbound and outbound traffic, you aggregate all your logs to a central point, and all these things. You have to have a security operations team, and you have to classify your data and secure your Active Directory network with things like two-factor authentication and smart cards. When this came out in 2009, this sounded like science fiction, like this would never happen. Now this is really happening all over the place. And this is what you have to do, because the nation-state attackers and their advanced persistent threats are so dangerous, and the major organized crime people can do it too, that you have to have layers of security and all these techniques to limit how much harm they do. And then there's honeypots. A honeypot is a machine you put up there just to be attacked. Antivirus companies do this. Microsoft runs hundreds of Windows machines in virtual machines, and they're automatically Googling for things and clicking on all these dangerous sites and getting infected, so they get samples of malware to put in their antivirus engine. Other people do it just to distract attackers. One very simple honeypot, for example, City College has 147.144.00/16. We have 65,000 addresses. We're only using 30 of them for public-facing web servers. I don't know if we're doing it, but one common measure when this happens is you take the addresses you're not using and you send them to a monitoring system, because anybody that's sending traffic to those addresses is an attacker. They're not trying to get to one of our servers that's really there. So instead of just throwing that traffic away, those are the IP addresses of the people that are attacking us right now. So it would be pretty smart to anybody that sends traffic within 5 minutes to like 10 addresses we're not using, we should just block that address and get rid of them, because they're obviously an attacker scanning our network. They're not here for any good purpose. Anyway, that's the game here. So a honeypot appears to be something important, like an email server or a database server, and hopefully your attacker wastes their time going there, and you have a chance for all these detection systems to detect an attack in progress before they find your real goodies and start stealing those. You can buy commercial honeypots like Spectre and NetBait. There are open source honeypots like HoneyD. There was a capture the flag competition about 9 months ago I was in, and they had this Unix server, and I tried to get in, and I used the password of 1234556, and I got in. And then I tried to do things, and almost none of the Unix commands worked. You could do an ls, but when you tried to open a folder, the folder wasn't there. You could list files, when you tried to print them out, they aren't there. And I was going nuts saying, what is this? And so one of the students actually noticed that it appeared to have a kernel from 2004. It was HoneyD. It was a honeypot. It wasn't a real server. It just looks a little bit like a real server, and a few commands will work, so it'll trick some people that are dumb enough, like me, into thinking I'm hacked into something. And it'll also take any password. Whatever you try, it'll just let you in. So you think you've got the password, you think you're getting somewhere. It has folder names that look interesting, but when you try to go in there, nothing works. And all that time, I was being stuck in a honeypot. It was pretty clever, actually. So there's virtual honeypots, are what a lot of people do. You run a service, and it just listens on one port and answers some questions. It's not even a whole machine. It's just one app. responding to a few things, making it look like one. Another thing you can do is just put up a real virtual machine that really has an OS, that really has a bunch of fake data. I'm pretty sure the FBI did this. One of the things back when Anonymous was hacking everybody in 2012 or so, was they dumped out the FBI director's email. And I read it, and it was incredibly boring. And I said, this is probably a honeypot. This is fake. Nobody could be this dull. There was not anything interesting. It was like, I'll meet you. This meeting will have been moved from 9 o'clock to 10 o'clock. It was all like that. Thousands and thousands of pages. Not one of it of the slightest interest. Anyway, so Project Honeypot was a trick, HoneyNet, where they had a whole bunch of webmasters would join this. This is the precursor to Cloudflare. This is what Matthew Prince did before he started the Cloudflare company. He started this open source project. You could join. You would connect. You would send the logs from your web server to his system for analysis, and then you would have the ability to add some code to your web page under his control. And he would add invisible code in comments that contained email addresses. So customers see your page and everything's fine, but an email address will appear on your page that's different for everyone that views it. And then he watches to see when someone starts sending spam to that email address. And by coordinating that receiving spam with the web server log, he can figure out what IP address the bad guys are using to harvest email addresses to send spam, and put them on hate lists, because there are a lot of global block lists of known bad IP addresses, and a lot of people subscribe to services where you download the bad IP address and block all traffic from them, and those are people that are known to be doing bad things like this. And this was one of the first attempts to do that. And eventually he started his own company called Cloudflare that does similar things, protects people and monitors traffic on the internet to find out who's good and who's bad. The use of reputation to rate IP addresses and servers and domain names is now very big. So you look at their previous behavior to decide whether you allow their traffic. Here's another one, the HoneyNet Alliance from New Zealand. Again, a similar thing is this will run your clients and they connect, and when they get an infection, it will harvest the infection and reset the machine to a known clean state, so it captures samples of malware. Another type of firewall you might want is a web application firewall. These are pretty important. If you have a server and people are sending in things like cross-site scripting and SQL injection attacks, a normal firewall is not any good, because it's not like the traffic itself is coming in on a forbidden port or anything. It's legitimate requests. It's just requests that will cause trouble at the server. So you buy a special firewall just for that. There's open source ones, like the one that comes with Apache Mod Security. And you can buy commercial ones. And in fact, if you take credit cards, more than I think 200,000 payments a year, you are required to have a web application firewall. That is one of the PCI requirements. So this is a special firewall just designed to handle layer 7 web attacks, which are not, we have a whole class in it, 129S, protecting web servers. There's a whole category of clever, deformed web HTTP requests you can make that do unexpected things at the other end. And so that's what they do. And like I mentioned, Cloudflare will protect you by running all your traffic through their servers, so nobody goes directly to your website. I've got it. So when you look at my website, you're actually looking at a copy of my page on a proxy server. The proxy server fetches it from my page. And so if you send any kind of attack, you're not attacking me, you're attacking Cloudflare. And they have a huge network spread all over the place. They have all the defenses. They can handle anything. And so nobody can take down my server. Except that I may be doing something which most Cloudflare customers are doing too. I'm not really hiding my real IP address very effectively. Most of them just leave it at the default, direct.domainname.com. Mine is at this attack server and everything. there are various places where my real address leaks out in all these projects. So I'm a special case though. Anyway, that's the game. Cloudflare sits between your customers and you. It used in real combat in summer of 2011. The Jester made enemies out of lulsec, and he wanted to take down lulsec's server that was serving up stolen data, but it was behind Cloudflare, and he got all of his gang to hunt for them, and they could never find them, scanning the internet trying to find them. If you want to do this right, what you do, you have your web server right now, it's serving up requests from your customers, you get Cloudflare's service, and then you move your server to another IP address, and then you configure your server to only provide service to the Cloudflare IP addresses. So if anybody searches the whole internet, they can't find you. The only way to see your page is to go to the Cloudflare proxies, and you don't accept traffic from anybody else. That's the right way to do it, and then you are very, very secure. It's very hard for anybody to take you down or even find out what country you're in or anything. Except, of course, that Cloudflare is subject to U.S. law, and government could come with a court order and demand that they tell them where you are, and I suppose they would have to comply with that. Anyway, I got a few more iClicker questions, and that's it. So, Which one relies on a computer's OS? I guess I'll quit at 25. All right, and that is host-based IDS. All right. Which one tries to trick attackers and waste their time? All right, I'll quit at 25. All right, and that's Honeypot, of course. By the way, there was a cute talk I saw. One thing people talk about a lot is hacking back. Why don't you attack your attackers? In general, this is a terrible idea, almost certainly illegal, very likely to hurt innocent people, but it never goes away because it's so satisfying to imagine I hacked them back. And one of them is there's a guy that says you should put, he puts malicious files on his honeypot so that when people steal his stuff, they get infected. Or it makes their stuff crash. And I said, is that illegal? And he said, I don't think it's illegal. I didn't send it to anybody. They stole it. The fact that they're stealing booby-trapped stuff, that's not my problem. And I said, well, you might have to talk to your lawyer, but it is an interesting idea, and there are people doing that. There's a variety of files that are dangerous. One of the simplest ones and oldest trick is a zip bomb. These have been around. Fork bomb is what you do on Linux. You make a file, which when run will crash the server. Fork bomb is just a series of Linux commands that will endlessly fork more and more processes until it uses up all the memory and crashes the machine. So if you open the file, your machine dies. A zip bomb does the same thing. It's a file that is designed so that when you unzip it, it becomes extremely huge, like 1,000 terabytes. So you can't possibly fit it on any hard drive. So when you try to unzip it, you use up all the CPU, then you use up all the hard disk space, then your machine dies. So you could put these things on your honeypot and let the bad guy steal them, and you might get some sense of satisfaction imagining the misery at the other end. I don't know. Anyway.
I like that idea.
Yeah, a lot of people like it. It makes a fun talk. I don't know if it actually does anybody any real good, but it is kind of cute to think about. Anyway, all right. So which one gives you the most protection from a SQL injection? Today is 4/29. All right. And I'll quit at 25. All right. And that, of course, a web application firewall is the one that actually knows about that kind of attack. These other devices typically do not know about it. You have to be specialized for web applications to do any kind of good job protecting people from those things. So I'll stop this. This is there, 123.13b.